Let's get started with the high security concerns in the graph DBMS. Before that, DBMS is a database management system which is an organized collection of the structural information or a collection of the data which is electronically stored in the computer system. We have different DBMS in the high security concerns. We'll be studying about the NEO4 and Orient DB. Let's get in a graph DBMS. A graph DBMS is used for storing, managing, and querying highly connected and complex data. A graph DBMS is an architecture makes it particularly well suited for the exploring data to find commonalities and anomalies in the large data volumes, and for also for the unlocking the values in data relationships. This is what the graph database is, and the introduction to the graph theory, which is a history of the graph theory, which is introduced in the 17th May 2001, and they have referred the article which is released at the 1736 by the Leonard Euler. The work arose from a problem known as the Kosenberg bridge problem. From a Kosenberg bridge problem, they have evaluated the graph DBMS. The problem was to go through all the bridges once and go back to the same starting point. It will be at the vice versa stage. And the Euler, which is who given the article about this, proved that it was not possible to do this. It replaced each sorting zone by a point and each bridge by an arc, thus creating the first graph designed to solve a problem. This case gives rise to the graph theory. So, based upon this article, they have introduced the graph theory. Nowadays, the current technology has allowed to take this principle to new types of databases. In case oriented to graphs, the information is stored as a nodes or entities or relationships between them, allowed to obtain an additional information of great value. Although it is true that is a technology is relatively recent, the most significant technology milestone starts from 2013. However, there are already certain databases that can also be in the real systems with success. The most famous graph database by its evolution and community is NEO4j and followed by the OrientDB. These are the popular databases which is used and their rankings. They are the NEO4j, OrientDB, Titan, ArangoDB, and Virtusa, Graph, AllegroGraph, GraphDB, StarDog, and SQRL. As we all know, SQRL is the most popular nowadays. And the security concerns, the main is our security concerns in NEO4j, that is in a graph DBMS, and strengths and the limitations of it. In 2013, NEO4j presents the first version of 1.9, NEO4j version 1.9, with a serious design flaws, including the possibilities of executing remote code using a public exploit. CVE 2013-72509 is a remote code to execute the DBMS. At the end of the year appeared the first version, and they have released another version of NEO4j DBMS, that is the 2.0 version. Earlier it was 1.9, where the visual in the 2.0 version of the NEO4G, where the visual section began to have more importance. It was also solved the problem of remote code execution and was added the possibility to have in HTTPS. And until the 2016, it was not evolved to new versions. Until 2016, the 2.0 version is stable and no further new versions were released. But in April 2016, in Graph Connect, the version 3.0 was introduced, adding a multitude of functionalities, new connection protocols, and the web administration panel disappeared. At the end of the and again at the end of the 2016, the new version before the 3.0, and in the year of the 2019 they released a 3.0 version and the 3.1 version with a great novelty of the implementation of the user management. The configuration and design of the each this version can be used by an attacker to try to access a database without credentials in it, and to be able to insert, steal, manipulate, and delete the information as shown the below. I will show the figure. And what's the main protection and the passwords in the DBMS? I mean, Graph DBMS, that is NEO4J. Or in the all versions of the NEO4J, that is 1.9, 2.0, 3.0, the key storage is stored in a file on the following path, that is dollar path and slash neo4j j dollar slash data slash dbms slash auth. This file is created when neo4j is started the first time, and at the end of the file appears pass slash word underscore change underscore required when the user by the browser when it wants to browse and wants to browse and access the portal. It asks for the initial authentication. When the passwords are stored in the DBMS, it is used for the authentication to access the files and asks to change it. The limitation of the passwords is that it contains at least one character, but it doesn't have a maximum characters and complexity limit. Also, it is not allowed to put on the same default password of NEO4J. Okay, in the passwords is it's only have a one character, and we cannot put a password as NEO4J as it's a DBMS name. So it's a drawback in the NEO4J Graph DBMS. It's certainly not the best robust password management policy for the Graph DBMS. The password is stored using the SHA 256 plus SAL salt algorithm, that without being a bad option. It is not the best mechanism against directory attacks, rainbow tablets, brute force offline attacks. So they are passwords are hacked by the brute force attacks, so which is not compatible for the users to use it. It would be advisory to use PBKDF2 and the NEO4J. What are the limitations and tips of the NEO4J is each entity table is represented by a label on the nodes. The every data is represented as a labels or nodes. Each row is an entity table is a node. The node the data is represented in the form of the nodes. The columns on those tables become node properties. The columns are itself they are node properties. The joint tables are transferred into relationships, columns on those tables and become relationship properties. The Neo4j tips, and we can see the flowchart of the node in the Neo4j, a node and node consisting of relationships and properties. That makes a node. And relationships of the Neo4j is the Neo4j has a start node and an ending node, and the what's the relationship type and its properties of the data, and the relationship type consisting of its name. It's a unique identity which is used to access it. And the paths in the Neo4j path is one or more nodes which connecting relationships typically retrieved as a query or a transversal result. A path or start node, relationship, end node, and node. We have already seen this nodes to node connection. We'll be seeing in the paths NEO4j. This is the end of the security in the NEO4j. I mean, graph databases. The relationships in NEO4j. Getting to the relationships of NEO4j, there are many relationships like we can see in the Twitter and the relationships. There will be four blocks: Maja, Alice, Oscar, and the William. The four will be connected with a follows blocks by these NEO4j relationships. And the properties of this NEO4j is the primitive data types are Boolean, short, lined, float, double, char, string. They all be divided and specified to their own states, and there's keys like property, value, search key, and the paths in the NEO4j. There will be a start node and end node, and the relationship paths. And the starting or stopping procedure in the NEO4j, there will be a code, and it starts with a graph db is equal to new embedded graph database bracket db path colon register shut down hook bracket graph db colon graphdb dot shutdown. It's a calling graphdb dot shutdown. It's a calling of that starting function of the NEO4j, and the private static void main. It's a main function. The main calling starts from here, and we can create a small graph by using this code. That is first node is equal to graphdb dot create node, and first node dot set property message hello And the printing the data, syncing out the data is a system.out.println first node.get property, and brackets two double colons will write the message. And this is the end of the NEO4j and the security in the graph database.